Okay, so we're going to learn section 6-2, and the class is going to say hi.
Hi.
Okay. All right. So everybody, we are moving into quadrilaterals now. Four-sided figures. There's lots of different kinds of quadrilaterals. There are parallelograms, which is what we're going to learn today, and what else? Anybody can think of anything else? Squares, rectangles, rhombuses, kites. There's all different types. Today we're just going to be learning about parallelograms. Okay, with all of these types of quadrilaterals, there are definitions that explain exactly what makes them what they are. And then there are properties that kind of happen just because of what they are. All right, so the first thing we're going to do is define parallelogram. Parallelogram is a quadrilateral with both pairs of opposite sides parallel. So on your notes, you can write little parallel signs here. Remember, these arrows mean that they're parallel. Both pairs of opposite sides are parallel. That's what makes it a parallelogram. That's it. That's the only thing required in this definition. Now, a lot of these definitions refer to the sides and the angles as opposite sides, consecutive angles, whatever. So we have to define what that means first. We probably pretty intuitively know what opposite sides are here, but they tell you AB and CD are opposite sides. What's the other pair of opposite sides? Why does it always do that to me? Go away. Okay. Uh, what's the other pair of opposite sides?
BC and AD.
Okay. BC and AD. So these two are also opposite sides. By definition, they don't share a vertex. Okay, opposite angles. By definition, don't share a side. They give you one pair. A and C are opposite angles. A and C. What is the other pair of opposite angles? Ren? Angle A and angle, oops, sorry. You said it right, I wrote it wrong. B and B. Good. Okay, so opposite sides, opposite angles. The other type of angles or sides are referred to as consecutive angles. Consecutive angles, we talked about this before. It means one right after the other. So either clockwise or counterclockwise, what comes right next to the one before it. So angle A is consecutive with angle what? B if we go clockwise, and D if we go counterclockwise. So angle B is consecutive with what? A and C. And C is consecutive with B and D. Good. Okay, so once we've established what those, how we're going to refer to sides and angles, now we can talk about the four theorems that give you the properties of parallelograms. So we already defined parallelogram. Two pairs of opposite sides are parallel. But there's properties that happen to become true because of that definition. So the theorems are written here, but I'd like you to actually turn the page. Because what I've done is taken the theorems and I've basically summarized them on this next page here into four properties. I think I started already for you, but possibly not for the people watching this video. So these four, one on the next page, are the four properties that you need to know about parallelograms. Okay? First, opposite sides are congruent. Next, consecutive angles are supplementary. Third, opposite angles are congruent. And the last one says diagonals bisect each other. So we're going to see how that is going to be applied to problems that you're going to have to solve. Okay? First of all, opposite sides are congruent. So again, this is not part of the definition of parallelogram. This is just happens to be true. If you have two pairs of opposite sides are parallel, then turns out they're going to have to be congruent to each other as well. So the markings will look like this. They don't tell us that it's a parallelogram, but we see that the opposite sides are congruent if it is a parallelogram. Okay, so here's an example. They could give you some expressions on the sides. Here, they're not even telling us that the sides are congruent. You just have to know the theorem. They mark the two sides parallel. So in your head, you're looking, you're saying, oh, it's a parallelogram. Aha, I know that theorem. It says opposite sides are congruent. So if opposite sides are congruent, that means LM is equal to ON. LM is equal to ON. So what equation could I write to solve for X? What equation could I write to solve for X? Yep, Jared. Good. 6x minus 7 equals 2x plus 9 because LM equals ON. Solve for X. And you get 4x is 16 or X equals 4. If X equals 4, here they just said solve for X, but they could ask you what the side length is. You would just plug in 4 here. 2 times 4 plus 9, 17. Okay? You try solving for Y. Okay, so since LO equals MN, 12 equals Y plus 3, and we get Y equals 9. Of course, we could plug Y back in here, and we're going to see that it matches 12 and 12. Okay? All right, so that's the first property. Opposite sides are congruent. These are going to be things that you just have to kind of memorize about parallelograms. Consecutive angles are supplementary. Consecutive now. One right after the other, either clockwise or counterclockwise. Consecutive angles are supplementary. So A and B are supplementary. What does supplementary mean? Add up to, no, 180. Supplementary add up to 180, right? So A plus B, measure of angle A plus measure of angle B is going to be 180. All of the consecutive angles. So B plus C is 180. C plus D is 180. D plus A is 180. All supplementary. Now, if we know that this is a parallelogram, you can think of it as two parallel lines cut by a transversal. What kind of angles are these two angles? Same side interior angles, right? Same side of the transversal, interior between the two parallel lines, same side interior angles, we learned are supplementary when the lines are parallel. So consecutive angles being supplementary is actually not a new concept. If the two lines are parallel, then of course these two angles have to be supplementary because they're same side interior angles. So that's what I have written over here. This is true because they are same side interior angles with parallel lines cut by a transversal. Okay, so the example we have here, if consecutive angles are supplementary, what's going to be the equation that I write? To solve for X, what am I going to write as my equation? Bria? So this one and this one, are those consecutive angles? 2x minus 60. Good. These two that you said first are opposite angles. Okay, so we're going to learn about opposite angles next. But these are consecutive angles. So consecutive angles are supplementary, so x plus 30 plus 2x minus 60 equals 180. Remember, your equal sign is there, so you have to combine like for terms first. 3x, and then negative 60 and positive 30 is negative 30, equals 180. Solve for x, and x equals 70 degrees. If we plug in 70 here, 70 plus 30 is 100 degrees. Let me just write 100. If we plug in 70 here, we get 140 minus 60 is 80. If we plug it in here, we get 100. If we plug it in here, we get 80. So no matter which two consecutive angles we look at, they're going to be supplementary. These two are 180, these two are 180, these two are 180. So consecutive angles are supplementary. If it's a parallelogram. What do you notice about opposite angles? These two opposite angles. They're the same. So that's our next property. Opposite angles are congruent. Opposite angles are congruent. So if you are given an example like this, where you have 2x plus 36 here, and 3x minus 5 there, you notice that they're opposite angles. You know this is a parallelogram, so you're going to set these two things equal to each other. Solve for x. X equals 41. If we were going to plug that in here, plug it in for x here, that's 82 plus 36 is 118. So this angle would be 118. Clearly it's not drawn to scale. It does not look obtuse, but we know that happens sometimes with our diagrams. They're not drawn to scale. Okay, so look at the next page. The very last property is that diagonals bisect each other. Diagonals bisect each other. So that means that if you draw both diagonals in a parallelogram, if it is a parallelogram, then this point where they intersect is the midpoint of the two diagonals. They cut each other in half. They bisect each other. So this is congruent to this. This one's congruent to this one. Does it mean all four of those segments are the same? No. But if we have an example like this and they tell you it's a parallelogram, then you have to know the theorem. Okay, so you see what's going to happen here? They're going to only tell you something's a parallelogram, and they're going to expect you to know what the theorems say and how to apply them to write the equations. So here, if it's a parallelogram, we know the diagonals bisect each other. We could say x plus 40 must equal 2x plus 18. Cut each other into two equal segments. So we solve for x. X is 22. If you plug it in, each of these segments is going to be 62 long. So okay, so let's practice here. We're going to try this. If we look at these problems down here, applying the theorems that we just learned, opposite sides are congruent. So B is just going to be 11. A is just going to be 9 because they equal each other. Number 2, same idea. X plus 2 equals 4. So X is going to be 2. And Y minus 5 is going to be 12. So Y equals 17. Number 3, we have to notice that these are opposite angles, and opposite angles are congruent. So Y minus 60 equals 56. So Y equals 116. And then opposite sides for X. 3x plus 4 equals 16. So x is going to be 4. Once we get to number 4, you have to look really carefully about what kind of angles we're looking at. You're not going to just automatically throw stuff equal to each other. These angles are consecutive angles, not opposite. If you look at them, they actually visually do not look the same as each other. This one looks obtuse. This one looks acute. So you're not going to just put them equal to each other. Consecutive angles are supplementary, just like same side interior angles, right? So f plus 30 plus 72 should be 180. And what did f turn out to be here? 80 something? Let's see, 108 minus 30, 78, thank you. Okay, and then g, we're going to just do 8g minus 3 equals 25. This came out to a decimal, 3.5, right. Okay, the last two apply the theorem that says diagonals bisect each other. So 9 equals 2n minus 1, and 3m equals m plus 8. And then the last one, 3j equals 5j minus 9, and 6k equals k plus 10. Your answers there turned out to be, I think I put them on the bottom for you guys, right? N is 5, M is 4, J is 4.5, and K is 2. Okay, your homework is actually this assignment right here. Page 364 to 365, 9 through 12, 14 to 16, and 25 through 30.